Good afternoon. Thank you. The conversation over the next sort of 75 to 80 minutes will be focused on semiconductors, semiconductor design from India, semiconductor consumption from India, and consumption across the world. The semiconductor industry has been around for a while, right? And just as a context, I worked for Intel for 20 plus years, and coincidentally, Intel was born the month I was born. And over the last sort of few weeks, as some of the Diwali cleaning progressed in my house, I found something which sort of was buried under my stuff a long time ago. And some of the chip heads in the audience will recognize this, that this is a plot of a chip. This is a physical plot of a chip. This is a 486. I think 90% of the audience probably didn't even know what a 486 was, but 486 came after a 386. The point here is that I started my career doing this for Intel as a EDA, as a software engineer, EDA. But the more interesting part of this was this chip, as we would call it, taped out at 100 megahertz. Now, for folks who are used to fast cell phones and stuff, 100 megahertz is as old and as ancient as anything sort of we can remember. Now, I bring this out for a reason. Semiconductor industries, as I said, has been around, but there are probably two or three moments in the last 5 years which has brought this industry back into the forefront. Number one being geopolitics, right? As much as technologists and businessmen and VCs we are, the geopolitics aspect is something which we can't ignore, and this has just brought this industry up front. Second one was the COVID and impact to the automotive industry, right? Where luxury cars were being sold in the market without some of the entertainment system just because the chips were sort of not available, and then the whole supply chain sort of got disrupted. I'll talk about the third one in a minute, but from the geopolitics angle and from the supply chain angle, a whole bunch of countries and the leaders sort of woke up to this and said, wait a minute, what's going on? What will this do to me and to my industry, etc.? And this whole, CHIPS Act type of thing started in the US, which is about $50-odd billion, which got assigned to it. And, some of it is getting rolled out. The third element, which I think is almost like a watershed in the last few years, is the arrival of, or the mainstreaming of large language models, right? The ChatGPT sort of became a household name. Now, while ChatGPT became a household name, the challenge behind that is just the availability of the fantastic silicon which some of the leading companies, including NVIDIA, built, and how supply short they have become, right? Net, if you look at it, the whole semiconductor industry has brought on to the mainstream to the extent where leaders, including our Honorable Prime Minister Modi, is now actively pursuing an agenda to build leadership within the country. That's my just brief introduction. The objective of this session over the next two panels is to give you a perspective of what's happening in India, what's happening by the esteemed startups being done in India. You'll hear from the founders waiting to get on stage, and we'll talk a little bit about what the market is. So without more background, I'd love to invite quickly, and we'll do a quick informal intro, Vinay Hebballi, COO of Calligo, please come on stage. Raghu Panicker, CEO of Kaynes, please keep that going. Deepak, CEO of Morphing Machines, please welcome on stage. And Neel Gala from InCore, CTO of InCore, please join me on stage. So while these folks settle down, what I'm going to do is, I know we're running a little short on time. I'm gonna dive right in, and we'll start with Deepak. Deepak, tell us about what your company does, and how in this whole context of semiconductor space, what are you doing out of India?
So thank you, Narendra, and a very warm good afternoon to the audience. So at Morphing Machines, today we are building out a reconfigurable computing platform. So if you want to think of us in terms of the parallel to the software world, think of us as a no-code platform for doing web design, sort of. We are trying to democratize access to custom compute. Say from everything from vision to 6G to life sciences, genomic sequence alignment, to maybe a vision pipeline, whatever your custom applications are, today you're restricted to a choice of few big names in the industry which don't give you either the bang for in terms of the performance or in terms of the power or in terms of the cost. There are some trade-offs to be made, and that's where our platform called as Redefine comes into play, wherein depending on what application you have, we are able to help you get to a silicon or design the silicon for you and give it to you in a finished form, which allows you to get the best in terms of power, performance, and area, and cost, obviously. So that's where the vision was for us, and I think thankfully due to a confluence of factors in the last couple of years where there have been a lot of tailwinds in the industry, I think there's a manifest sense of destiny in the semicon space, at least for us fabless peers, right? Because we've always been very efficient with scaling SaaS, software enterprises, but there's always been an invisible line, I guess, somewhere, which says that, hey, you cannot do deep tech, right? And I think that has kind of gotten erased. And over the past years, I think both in terms of the Indian semiconductor mission, support from the venture industry, I mean, maybe not so patient, but yet just patient enough capital right now, and capital efficiency also. So I think all of these things have come together to kind of make it the right time, that if it is not now, India will never catch up in semiconductors ever again.
Okay, so time's now. Raghu from Kaynes, tell us about why you're excited about what you're doing.
Sure. Before I get into Kaynes Semicon, just wanted to take you through the last 34 years in the next 1 minute. I started with a company called Semiconductor Complex Limited, which is a fab company in Chandigarh. Many a times the question is that, does that company exist or not? It does exist. It does exist for a very good reason. The chips that come out or the semiconductor devices that come out, you see it in the DRDO equipments or you see it in Chandrayaan and stuff like that. So, yeah. So that's the company that I worked for 10 years.
And we'll hear more about that in the next session.
Okay. So a little bit of the past to that. That's the first company which thought about semiconductor system. That's the first company that thought about tier 2 cities that we talk now, because they had design centers all over India at that point in time. The second company that I went on to work was the EDA company, which you spoke about. That was a company called Mentor Graphics, which then eventually bought out by Siemens. And the third to AT or a test company, which is Dassault Semiconductor, and now part of Kaynes Technology, a subsidiary called Kaynes Semicon, where we intend to put a OSAT plant in India and probably take care of all the challenges that we are facing on the semiconductor parts availability and stuff like that. So that's the intent of Kaynes Semicon. We just did a groundbreaking of the OSAT plant in Telangana, and we intend to do certain power products which would eventually get into the automotive segment.
Awesome. Thanks. How many of you in the audience understand the term fabless?
That makes my introduction small.
Right? So I'm just setting it up for you.
Thank you. Very good afternoon to everyone. And InCore is, to put it short, InCore is a RISC-V solutions company, right? And what we are selling or what we are promising our customers, or the gap we are addressing in the market, is custom silicon, right? At InCore, we strongly believe that we've already entered the era of domain-specific compute, right? You are out of the world when you're going to talk about general purpose cores, right? There are newer computes, there are newer workloads coming in, deep embedded. You're talking about LLMs, but even in metering devices, automotives, motor fans, whatever you look at, each of these electronics, each of these IPs, or each of these silicons that you're looking at is very customized, right? And at InCore, we are a 5-year-old startup. What we've been working on.
Sorry, I'm going to interrupt you. So when he says customized, right, I'm going to simplify. This is in contrast with a chip which is on your PC, which is a pretty standard chip, right? Just we're getting the audience warmed up to the concept of semiconductors, so go for it.
So absolutely. So custom is, yes, the opposite is what you're looking at your phones because you're going to be running any Android app, but there are certain workloads, there are certain things around you, for example, smart homes, smart home devices, smart fans. Each of these require a specific different type of compute. They're interacting with sensors, some of them have a lot of memory, they're communicating with data centers and so on. So each of these requires a different set of silicon, right? You can't retrofit them with the same stuff all over again, right? Every single time you can't keep reusing the same chip. And at InCore, we're sort of delivering this using the promise of RISC-V. RISC-V is a new instruction set. It's open source and it's free to use. What we're doing is adding our secret sauce and building chips for you, which are tailor-made for every single device that you can use, right? And we are doing that in IP form, and in the recent couple of months, we are also aggressively entering as in sort of a virtual ODM, a one-stop shop, where you can sort of come up with wild features that you want to do for your electronic chip. And we have the entire ecosystem from spec to silicon, using our partner ecosystems like HCL, Tessolve, and so on, where we can go all the way production and mass volume deployment for a single customer. Right? So that's a short note on RISC-V.
How many of you know have you heard of RISC-V? So, I'll give you a quick primer. There's something called instruction set architecture, right? This is the language which the processors are designed on, right? You give it an instruction, there's a set of instructions, they do their job and they give you the result, typically referred to as ISA. The dominant architecture in the industry was from Intel, where I came from for a long time. Most of your phones has something called an ARM or ARM derivative, right? ARM, which has recently been in the news, right? The other architecture which is coming up is what Neel referred to as sort of RISC-V. I'm just giving the primer along so that people can follow on. The idea here is this architecture is open source and you can do lots and lots of innovations on top of it. All right, thanks. All right, how many of you know what is a floating point arithmetic? Okay, that's better. So you have a better setup now.
Thank you.
This is the ability to do very, very, very precise calculations and very advanced calculations. Now, Vinay and Calligo team have something more cool to offer.
Good, thanks. Good afternoon to all of you. So Calligo is a company focused on developing the silicon as well as developing the system. So we will actually have a complete solution which will comprise of the silicon, the hardware, and the software. So it's an actual end product. So I've been part of this company now for the last couple of years. Previously, another startup successfully created called Graphene Semiconductor, exited it in 2018. So this is the second startup that I'll be involved in. So to all the people in the startup, yes, there are successful startups that we can do based on the ecosystem that we've been having here. So primarily Calligo is focused on, thanks to Narendra when he talked about floating point. So we've been living with this number system for last 30, 35 years, right? And we all are aware that it has its own challenges. It has a lot of advantages, but we are also starting to live with its challenges. So why should we be living with its challenges? Stock exchanges lose a lot of millions of dollars because of rounding off errors. There are not a number kind of errors. You cannot replicate the same result from one platform to another platform. So these are the challenges that we've been living with. So we no longer need to live in. So we've adopted an alternative number system called POSIT. This is a number system that brings in superior accuracy compared to the floating point number system. So we have taken the RISC processor, right, and we have replaced the FPU with our floating point, with our POSIT number system as a co-processor. We developed a silicon. Just last week, we were successfully taped out the silicon based on the ecosystem that's already available in the industry now. We now would get the samples, we would manufacture the boards, and we would start supplying these boards as something that can go into your x86 or an ARM-based system. No need to unlearn, no need to learn any new kind of a stuff. The entire hardware, software is a complete solution that we will be providing to all the HPC, high-performance computing platforms in the industry. That's a quick brief.
So Vinay again churned out a few acronyms. I'll just, dumb it down for myself and for the audience. Tape out is a term which, these geeks use when they are done with the design and, throw the documents at the factory guys and said, listen, we've done our job, you better do yours, and when it comes back, stuff should be working, right? The problem with the semiconductor industry is when you ship it to the factory and when something comes back, you can't go exactly fix bugs that easily, right? Unlike software, we ship code over the weekend, didn't work, change a few things, put it back online. So it's a pretty big deal to get something taped out, send it to the factory, and there's a lot of sort of diligence behind that. The other thing which I want to highlight from Vinay said is there's a lot of things he mentioned at the complete stage of life cycle of design, and that's what we sort of wanted to highlight. Maybe I'll start back in this order.
Sure.
What's the environment right now? Why are you doing it in India now? Just move to the valley, get it done there, ask somebody to do it. Why are you guys here?
True, I think it is. If you look at the kind of technology that we are investing our efforts in, this is going to be disruptive. It's not something like Me Too in the industry. If it's a Me Too, we can go to an existing industry player, ask him to repeat it for ourselves. If you're copying a design from another silicon and implementing it here, you can obviously replicate it. Here is something which the founding team came up with a niche idea to deal with something that's not been as a solution for last 30, 35 years.
Would you categorize this as something completely groundbreaking, nobody else is doing, very few people are doing it?
Completely unique. In fact, this as a number system still is in the research stage. Calligo is the first company in the world to bring it into a silicon form. So we will have a real silicon. We are working with the inventor of POSIT number system. Day before yesterday, he said the kind of hardware and the software that we have put together is the first in the world to even come up with this far a solution actually.
So one last point. Who cares? What's the benefit?
It's meant to focus on addressing what people are trying to live with as a problem for the last 30, 35 years. There is an alternative solution, and the founding team believes that we can bring in a disruptive solution to address the market challenges.
Awesome, awesome. Thanks, thanks. And congratulations on that journey. So we'll see how the numbers shape up. Neel, similar question to you. Why are you guys doing it? Stuff has been showing up in the country for so many years, cameras, devices, etc. People have been doing custom stuff for a long time. Why now? Why from India now?
Good. I mean, the last point was very important, right? Why India? And that's usually the case with a lot of semicon. Is why aren't you doing this in the valley where it all makes sense, right? So, a couple of things. There's a lot of ecosystem in the consumer electronics, right? India as a market player is starting to see a lot of homegrown products, right? We are no longer, I mean, we figured out the supply chain, we figured out the sourcing, we are able to assemble here, we are able to create here. And more importantly, these creators or these startups who are building companies who are building the consumer electronics, they realize there is a need for innovation, there's a need for creation. The differentiation is key for them to win the market. This differentiation, this need for differentiation is where they can only be achieved through custom silicon, right? And more importantly, why India? Well, if you look at the VLSI world or the semicon world today, India is at its peak when it comes to services, right? We build the best chips or we deliver the best chips in the world to someone else. So we have the ecosystem where we can take a design from someone else, do a physical design, synthesis, place and route, get it to the fab, get it back from the fab, test, validation, OSATs, everything. The one key piece that was missing is design, right? We're slowly getting there, and InCore is playing the primary role there as a CPU provider, right? As a processor provider, and we're sort of bridging that entire ecosystem gap, right? So working with this ecosystem which already exists in India, shifting the momentum from services to creation, to design IP, and leveraging the fact that there are consumer electronics and products already happening in India, why cross borders? Right? If I can build an entire supply chain, if I can have more visibility, if I can have more control, I don't have to cross borders, I don't have to go to my neighbors, north, south, east, west, and I can control my destiny, right? That's the sort of pitch that we are looking ahead of, and that's the future that we are very proud of, venturing into.
Awesome. And I know I should have asked this question to both of you, but I think one of you can answer it, is that when these guys finished the design, and I talked about shipping stuff there, where do you ship it? Who manufactures it for you today? Very quickly.
So quickly, the current silicon that's on a 28 nanometer, we're doing it at TSMC.
TSMC is Taiwan Semiconductor,
Taiwan
guys.
Semiconductor.
This is the epicenter of argument between a few countries.
Right. So that was the best choice that we had in terms of the node that was available, the technology node of 28 nanometer.
Okay.
From an affordability standpoint, again, that comes in as a factor, from a financial factor for a typical startup that's there. We would have loved to do it in a much better node like a 10 nanometer or a 12 nanometer, but we had to stay with 28 nanometer. And it takes 84 days for them to manufacture it and give it back to us.
28 nanometer is still relatively state of the art for a lot of people, but we'll get to that. Neel?
Oh, I think the answer is the same. Taiwan is definitely the first choice. The alternate choice is global foundries. both of which, especially the domain that we are working on, we're not looking at cutting edge stuff. We're happy with 90/45 because that's the embedded space where we're looking for low power maturity, and price war is what we'll end up doing. And these are the nodes that will give us the benefits there. But definitely it's Taiwan and Global Foundries. Those are the two major players that we look up to.
Raghu, with your depth of experience in semiconductors, especially in India, right? What do you see is different now? How are you able to operate better, faster, cheaper as compared to maybe about a decade ago?
Yeah. So, the three gentlemen sitting to my left and right, pretty much comprise of the startup, which is quite good and little unfortunate because, we would need more of them, right? But then if you look at a unique between three of them is all they are on a RISC-V open architecture. That's again an advantage because we are not pretty much dependent on the early architectures and stuff like that. And all three of them are coming out with unique products, which is for India. Now to answer to you, we had earlier challenges of saying that, people move towards services. Why is that happening? Why are people not doing products out of India? I would feel that that was a better one because at least people went to services, learned the tricks of the trade and then came back and did product startups, right? Vinay is a good example of that, right? So why not? Also, we've been told that why do people work for only for multinational? Let people work for multinational, gain experience out of it, come and do products. So that is also not a bad thing, right? So both the kind of world should exist, and then we should have those challenging products done. What I see now in the last 20 years, we are a big design powerhouse, at least in the semiconductor chip design. We are second to none. We are a center of excellence, at least in all the multinational companies where we own product from the architecture to the entire product design and manufacturing. So that's a job well done in the last 20, 25 years. And that did not happen over a period of one day. It happened with university collaborations. It happened with EDA collaborations, right? EDA guys brought in all those tools to India and stuff like that. It also came about with all the finishing schools that came into India. People who studied from the 7th and 8th semester went on to learn, chip design and the entire process outside of the scope of colleges and learned that and came back and worked. So that aided to it. Right now, at least in the last 3-4 years, what I'm seeing is a little bit of a change. There's a big intent from the government. And that intent we see is to put up a semiconductor mission, is to put up, talk about, my erstwhile semiconductor complex to be turned into a research center, to talk about a separate India semiconductor vision to be created within MIT. And I'm telling you, ISM, India Semiconductor Mission is pretty fast because within Kaynes, I represented Kaynes Semicon and we're putting a DPR over there. Before I send the DPR, the next day I get a call from them about queries. So I see them to be pretty fast. Same is the case with state government. Without taking any names, all the state governments would come to you if you go and talk to them saying that, you want to put up a plant and stuff like that. There are many of these state governments and all the state governments come to you rather than you going to them. Guys have single window clearance. Guys have pari passu as a concept and stuff like that. So those are the few things that are happening in the last, 3 to 4 years. But I do have a challenge as well. Now, when I go to put an OSAT plant, I know that packaging expertise of people who have learned packaging, they do not exist in India. So which means that you have to create that market. You have to work with IIT Chennai, IIT Mumbai, and few other, colleges. I dare not call tier 2. Because we need to bring all of them and get them to that bandwagon to learn packaging, learn testing. Before 6 months, when we put our first line, and we have these kind of people available to run the machines and stuff like that. So, in a nutshell, what I see is the challenge, which could be an opportunity for us, like if we have become a design powerhouse in the last 20, 30 years. I'm sure in the next 10 years, when you look back, we would be a manufacturing powerhouse from the semiconductor design. Even though we start with doing this work for somebody else, maybe manufacturing chips for the multinational, but I'm sure, with the likes of my colleagues sitting here or industry colleagues sitting here, we would be doing some of their chips as an OSAT within our company and say it proudly as a fully made in India, minus the fab. Mostly by that time, the fab will also be in.
Well, fingers crossed. So absolutely, thank you. You covered quite a bit of the ground there in terms of the industry environment. Morphing Machines comes from a very strong research connect, right? Your founding team, has phenomenally talented, technical. Now, it's not that the talent was just new. I mean, the talent has been built over several, I would say, almost a decade plus, if not longer, right? Can you expand a little bit more on what Raghu said in terms of just the talent in the industry, right? And then also, why are you doing it here, and how do you see this sort of going forward? And I'll finish the last question, and we'll prefetch it for everybody, so you can finish in terms of where do you see the crystal ball going, and then we'll work backwards. We'll watch the clock. As you guys know, clock is important in a processor.
Absolutely. So. Everything's a clock, yeah. Yeah, so to answer your question, I think, with the kind of processor platform we were building, or rather an accelerator platform, right? We're not a CPU, we are more like a GPU, but a GPU which can cross boundaries.
By GPU, log rule kar rahe hain abhi.
Yeah, I know, but we want to kind of, at least give them a run for their money. Yeah. So while the tech team was always in place, if you kind of ask me and I look back at our journey, what I noticed is early on, the discussion would always be around technical excellence, would be around features, would be around, design features or innovation in isolation or in silos, right? Hey, a data flow accelerator, which is what we were, has never been done before. A reconfigurable accelerator has never been done before. Now, what is the utility? And, one of the earlier questions you asked, why should you care? Or why should anybody care? That gap or, that journey towards productization was never there. I think in part because, we were all designers, and once we designed and taped out and verified, we sent the chips back to stateside, right, or Europe. So I think that knowledge was missing, but also I think because of lack of capital at that particular point in time, and an understanding of what deep tech requires, like, silicon and all of these things, there's a inherent lack of confidence in founders themselves. Either you were outright rock stars like Parag Naik from Sankhya Labs, who fought a long and lonely battle, and, he was one of the first people to make it through, but he was the only person who did it in that sense, right? Without international backing or, some of those things. So for the rest of us mere mortals, it appeared like, hey, we don't have the chops to make it a product. I think the best we can do is, come up with an interesting set of features, something which has never been done before, and then, hope that some multinational takes a little bit of liking to us and, then buys us out. I think, but with the tailwinds which happened, right, vis-a-vis the geopolitical situation and supply security and all of those things, there was an awakening, and definitely the ISM in Indian Semiconductor Mission, and also venture capital interest. I think, those were two critical parameters which actually helped us mature, our thought process from, hey, this is a product, but rather, now the product features are secondary. Yeah. But hey, now my language has changed from, I am reconfigurable, I'm this, I'm XYZ, to, hey, I can save your company 80% time to market. I can save 90% power for you. I can give you ASIC level performance for 10% of your capital expenditure which are typically done. So it's changed into business value proposition in terms of how we all see ourselves recently. And this has gotten us a seat at the table, for even in front of multinationals today. Even they'll take us seriously when earlier we didn't take ourselves seriously in a way. So in fact, for all the AI ML enthusiasts, we will exhort you that, your next generation of products should be running on our chips together, and not, some international chip, because, we'll give you better power and performance. So I think this confidence is what was lacking earlier. And if you were to ask me in terms of a global perspective where we are headed, or the crystal ball glazing, right, I think it is breaking the global barrier. I think it's well understood that India is a good domestic consumption story, wherein, a mix of feature and cost, or feature and price play will, bring about that switch for device manufacturers in India to switch over to a domestic alternative on RISC-V, one of us. But I think the true seat at the table will be when we actually are exporting internationally. Absolutely. And that I feel is a very difficult journey. We don't have any answers. Hopefully together we'll figure out. We've talked about ganging up.
We'll get there soon, right? And with all your efforts, right? So now we're in the overclocking mode. Very quickly, crystal ball, 30 seconds on where do you think the industry is headed?
So from our side, at least with the OSAT coming up, and specifically touching upon OSAT, what we believe is that, other than servicing the big multinationals and stuff, we are looking at startups, we are looking at product companies in India. We're talking to a couple of them in the IGBT space, in the surveillance space, where, they have the products available, and we'll do an OSAT over here. So 4 to 5 years down the line, when I look at the subsidy challenge going away, that's when the price point and all that will start to tick in.
Yep.
So India is the market that we should look at, and the volume is here. So why look outside?
All right, Neel, how are you going to put $3 million to work to make lots and lots and lots of more money?
So my mantra that I'm going to spread is why not India, right?
Absolutely.
I think that's what's going to happen. People are soon to realize and stop fearing that India can't make chips, right? I think that's going to break down, and there's going to be a lot of awareness that we'll have to do with the government, with industries, with MNCs, that it's possible and it can be done at par, at competition, at the best quality, and even better out of here, right? And as I said, consumer electronics, that market is slowly getting up. They have a need to differentiate themselves at the global scale, right? And we can serve that here, right? That's the kind of awareness, that's the kind of push that we're going to be doing in. And I think it's going to be a very warm welcome. I think people are already looking at, we have customers who said, oh, you can do this and this can happen out of India. That's amazing. So they've gone back to the drawing board, trying to innovate on their own product, saying, oh, if I have this, then what else can I do, right? So awesome. I think that revolution is coming in very fast.
Awesome, thank you. Very quick wrap up, Vinay.
Sure, so let me just take going global. Our previous speaker talked about collaborations that are extremely important for startups. These are the 2 points. If you see, we're starting to look at working with Barcelona Supercomputing to make sure that our presence is felt over there. We're talking to NSCC in Singapore for adoption of POSIT as part of their petaflop computing activities. We're talking to Square Kilometre Array in Australia for terrestrial sourcing. That's another area. So going global and collaborations are the two extremely important for us to break the barrier from India Limited and looking at how adoption of the work that we do, the design that we do, can be adopted across the world actually.
So ladies and gentlemen, these are the rock stars who are truly amongst a few breaking ground in an industry which is nascent, at least from an India perspective, is very mature across the globe. So I see a hand raised. I'm not sure if we have too much time. But what we'll do is, I know all of them are around, and we're going to have one more panel on semiconductor. We're not finishing up. So you're happy to catch them up, but I'd request you to give them a big round of applause. These guys are truly breaking ground, working against all odds. So thank you. Thanks a lot, gentlemen.